Это клетки обезьян?
Hello, Ilya. Thank you for...
My name is Leah.
Ilya?
Leah.
Ilya.
Leah.
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 Leah, okay.
Ilya is a male name in Russian.
Okay, thanks for the lesson. Good afternoon, Leah.
Hi.
Thank you for giving us time for a second interview. I would like to go a bit deeper into some questions. I make a little research and I see that your last studies about some viruses attacking the bees.
Oh yeah, that's true.
Yeah, could you tell me a bit more about it? What this virus does to the bees?
Well, this virus actually, yes, you're right, it's attacking the bees and it causes an asymptomatic infection. So basically the bees look fine and the next day the beekeeper comes to the beehive and the bees are dead. So it's very rapid and well, it's like this. So actually, let's say the viruses of the bees, it's quite a common trouble because there's like plenty of them and it's one of the reasons why the bees are dying across the world.
Yeah, yes, we
like
have seen in the last years the bees are on, I'm not sure if it's still on danger extinction, but they're on danger.
Well, they are, I wouldn't say that they're on danger extinction, but however, like let's say now it's affecting beekeeping quite roughly. And as well, there is another problem that some of the bee viruses, they infect not only the bees, but for example, bumblebees and some wasps, etc., and the other insects. And this can affect the pollinators. So, and this can affect the plants and ecology.
Yeah,
ecology
it's all connected to
yes.
us. And how this virus is spread on their case? Because, okay, in humans we know the bee sneeze, but how they get infected, how they have some...
Well, usually for the bee viruses, most abandoned route of spreading the virus is with the help of the so-called parasitic bee mite. Parasitic mite. It's called Varroa destructor, and basically the mite it sucks the hemolymph of the insect, and then it crawls to another insect, bites another insect, and
so it will be like a bubonic plague. We have the rats, and they have these little mites.
Yes, yes, yes.
And if you manage to find a cure, okay, or how it will be spread, because we cannot make a vaccination campaign, we cannot make them pills. How is actually this in science, this kind of implementation for insects?
Well, first of all, we don't work on discovery of a cure because it's already not our specialization, I would say. We've been working on the solution of the structure of the virus, so now we basically show how it looks like and where there can be weak points to find a cure. So, and this is more the task for chemists. But however, if there would be a cure, I would say that most probably you can spread it on the beehive as, like, I don't know, as some spray, or it can be feeded to the bees when they are getting feeded by
so like some kind of chemicals through to the plants where they go and feed, and it's just keep the change.
Yes, that's most probably the way.
And after you will finish because I think you are studying now your PhD.
Yes, yes, that's
After you study, you have an eye on some virus, like, okay, Ebola, I'm going for you. Like, which will be your favorite virus to study?
Well, I cannot say which is my favorite virus to study. I only had like 2 projects, and one is exactly the bee virus which you mentioned. It was Kashmir bee virus, and another virus which I'm studying is a human echovirus. Both of them are belonging to Picornaviridae, so they look kind of alike. So they look like, you know, they have an icosahedral shape, so it's like kind of like a football ball plus minus. So nothing that extremely different. However, in our lab, people also study bacteriophages, and those guys are extremely cool. They look like, I don't know, like some weird spaceships. They have a head, they have a tail, they have a tail fibers.
So bacteria you mentioned.
It's bacteriophages. So it's the guys which are feeding on bacteria. Not feeding, they are propagating on bacteria. Because obviously viruses doesn't need.
Yeah. Also, even there is an ecosystem between all this microbiology.
What do you mean?
Like I say, these are feeding on bacteria.
Yeah.
So it's even between them, they have as well their own issues ongoing.
If we are talking in general about the viruses, there is no species which is not affected by the viruses. So yes, of course, there are viruses which are propagating on bacteria. And it's actually quite important for us because, well, there is an implementation of use of this bacteriophages in medicine, because that's the way how you can avoid the usage of antibiotics, because nowadays there is a huge trouble in antibiotic resistance.
Yeah, because they are not properly taken or like
yeah, because of
bad treatment, etc. Because I know we have it in Peru. I know with the resistant tuberculosis, because the bad treatments, they don't follow the process, and then actually the virus gets stronger.
Yeah, well, the bacteria gets stronger, and it's impossible to cure it after. There is also staphylococcus infections like this, and well, I mean, this is actually quite a problem now. It's due to people not taking antibiotics properly, due to people taking antibiotics not prescribed to them, etc. So, and there is another possibility how to avoid the usage of antibiotics. It's actually the use of the phages, so phage therapy. And there, basically, you provide the phages to the patient, and since the phages, they are very specialized, so they're gonna attack only the bacteria of the interest. So they're gonna kill.
So there is the effects there are going to be less side effects.
There shouldn't be any side effects.
Wow.
But the thing is, it have to be studied very well before.
So it's just at the beginning, in the middle, in which stage is now that kind of?
Well, it's I would say it's running all the stages, because I guess there is so far just one institute who's really doing phage therapy, and this one is in Georgia. And here we study this on the molecular level, so we are investigating how phages are built up, which receptors they use, so we can plus minus predict which bacteria they're gonna attack. So, for instance, you have to count that that there is not going to be any trouble with human microbiome.
Wow.
So.
Cool stuff.
Yeah, that's
really
pretty cool stuff, and I really love this branch of the research which people do in our lab. Unfortunately, myself, I haven't had a chance to touch it, but this is extremely difficult.
Moving back to the point that some people is not following the proper treatment, but there are many reasons. But I read an article like many months ago in National Geographic saying about the science on war. That many people is disbelieve in science, like we didn't go to the moon, they don't believe in vaccines.
Oh my God.
A lot of this kind of weird stuff. What would you say to? Because I know that even now that we have we're still in the pandemic, people, oh yeah, we need scientists. They start to give more funding when always if a scientist wants to study a project, is the last on the queue to have priority for funding.
Well, this is very, how to say it, like it's very social problem, because yes, science is not supported as much as, I don't know, for example, pop culture, let's say, or football. So scientists do not get like huge salaries, and there is, well, there is not that much of a motivation for young people to go to science, because you know that you're never going to be rich. So people do science for love. Basically, they have, let's say, they are curious, they love investigating stuff, and then they go to science. But you have to count on that you're never gonna have like houses,
knocking
cars.
doors.
Yeah. So, and talking about the trouble that people do not really believe in science, that's also the trouble of our mass media, because hoax theory is really easy to sell, because Usually how it looks like, it's usually people who doesn't really have an education. They write some kind of a posts, and in the post they use 2 or 3 scientific terms which are totally not correlated to the post, if you know what they mean, but they look kind of smart, but the rest text is written in very easy language, so people can read and understand, and they believe it.
Hi Leah, thanks for inviting us here. We know that you're a virologist and we know that you're from Russia. So what are you doing here?
Well, first of all, I'm a structural biologist and I'm doing my research in virology. And yes, I'm from Russia, that's correct information. Well, what I'm doing here, I'm doing my PhD. And well, basically I'm doing research.
Research?
Yes. Basically we're doing structural biology and we investigate how the viruses look like, how do they function, how do they infect and propagate in the organism of interest, let's say. It can be whatever, it can be human, it can be insects. Well, you probably know that the viruses, they are well spread all around the globe and they infect almost every species known.
So we can say it's like a new lab?
Well, the whole institution is quite new. I think there is like less than 10 years.
Less than 10
It's
years.
existing, the lab is existing around 7 or 8 years.
Cool, so you have all new technologies, not like
Oh
it
yeah,
happens.
well yeah, let's say SciTech is very well equipped. We have absolutely almost everything we need. Let's say here are a lot of modern equipment, like here is a lot of modern equipment, like for example we have very strong cryo facility, it's cryo-electron microscopy facility with awesome, absolutely astonishing microscopes. Then we have, well, basically we have everything.
I wanted to ask you, how did you actually feel 2 years ago when all this COVID thing started? Were you scared or were you excited about, oh yeah, something new? And how is it like to wake up as a rock star one night?
Oh, well, not really a rock star, let's say. But, well, when the pandemic just started, for us, well, we've been, I think, rare people who were not scared, but mostly excited, because there you can see how it's actually going on in nature, and, well, it's incredible. This is like, not like, oh yes, because you know that there is going to be like a huge mortality rate and it's not going to cause anything good for people. However, like a scientist, biologist, virologist, you just excited to see that it's how it really works, how it's really propagating, how it's existing, etc. So, well, but actually when it was when it's all started, but then like when you know you live through it and you realize that it's like it's really scary thing, of course, and plenty of people gonna suffer, plenty of people gonna die. So I know personally a couple of people who died.
How did you find out about this new virus? Do you have some sources, or like all of us from the news? Like some.
Well, we found out like all of us from the news because, well, you know, there is like I can talk about this hours and hours, but China wasn't really open about what's going on, and basically even the samples of the virus to be investigated first were not obtained from China. Even like multiple labs asked them to provide the samples, but they first were obtained in Australia from the patient who came from China. So, for example, like, you know, the pandemic just started and people around the globe just providing their, not providing, but like they suggesting their help to investigate and to get to know with the source of infection as soon as possible, and China just say no.
Oh, okay. But so like he was not prepared anyhow.
Well, I mean, We didn't deal with this virus at all. So there was an idea to study the structure of it, but at the moment when the samples were available, there were already multiple labs working on the structure, and we decided not to jump in because it's going to be mostly waste of time.
So maybe let's move to another topic, which is actually connected, because I wanted to ask you what happened to the viruses we already defeated, like smallpox, Ebola. Are they stored in labs? How? Do you have some?
Well, I wouldn't mention Ebola as defeated virus.
Okay.
The source of Ebola is still, like, how to say, propagating somewhere deep in Africa, and it's highly likely that it can come back. It's possible. Talking about smallpox, for example, I would say that yes, this virus is defeated thanks to vaccination. However, of course, the source of the virus, like, there are a couple of viruses, couple of labs, I guess something like maybe 3 of them, who still have this virus stored, just in case if once there gonna happen another outbreak. Because you never know, the source of the virus can be stored somewhere in nature and it can come back.
Okay.
So,
So do you have some?
well, the maximum biosafety level which we have here is BSL-3, which is not enough to have something like Ebola.
What a shame.
Yeah.
But anyway, are there any security measures that protecting viruses from escaping? Like
Oh yeah, of course. I mean, if you study some things like this, you have to be aware that you are not bringing it home. For
like
instance.
how?
Well, it depends. So there are like a couple of levels of biosafety. It's from 1 to 4. And of course the 4th level is the most harsh one, where, you know, probably you've seen it in the movie where people are in this like cosmonaut outfit, working somewhere in a lab, totally like covered, isolated, etc. We have maximum biosafety level 3 here, which is also people in outfits, and it's also like you have to, when you go in there, you are taking your clothes off, and then you are like changing for this special outfit. You work there, then you have the autoclave there. So basically, if you work with some infectious material and you need to clean it up, you can directly autoclave it there. So nothing which comes nothing comes out from this lab, like nothing alive comes out from this lab. And as well, when you're leaving, you are taking your shower, it's like obligatory. Then we have biosafety level 2, and here we work with viruses which can infect human, for example, but they're not gonna cause that severe symptoms. And here you have Flumhood. So this basically the box where you have this laminar flow. So basically, once you take some stuff inside there is like sterile environment, and when you work, like you put your hands in the gloves inside.
Oh yeah, I know.
And when you work there is nothing coming in. It's not going to contaminate your sample, but it's also nothing coming out, because this laminar flow, it just, you know,
the lower pressure.
Well, it's not. There is no pressure. It's just the flow of the filtered air, and it goes in and out inside of the thing.
Oh, okay, I got. So it's like closed. So I wanted to ask you about other important virus we have outside is AIDS. And first of all, I think if you take it like a serious pandemic now, another thing, if you like connect it with it, I don't mean like you have it, I mean if you like research it.
Well, I mean, first of all, the virus is HIV. It's not AIDS. AIDS is the disease. And well, we do not work with AIDS or with HIV here. But I think one of our co-workers had a collaboration with another lab, but it was like a while ago. I'm not going to talk about it. So, and well, about the pandemic and about the current situation of the spread of the HIV among the human population, yes, definitely yes. It's running in the population like crazy, and especially if you will take such a countries like, let's say, I know how the things going back home, like in Russia, it's really, really huge deal. I mean, statistically, like, you can be really surprised if you like count.
And what about Czech Republic? Do you know anything?
I don't really have the information about the Czech Republic.
Because I feel like here, I don't know, like people forgotten, or I don't know, it's just my feeling.
There is, let's say, there is no vaccine from HIV virus, so once you get it, you get it. And yeah, but however, it also depends pretty much on the way how people who has HIV are treated, because there is this antiretroviral therapy,
like medicine.
Yes, this is medicine, and if people are treated with a medicine, they can be on the level when they cannot infect anybody else. So the virus titer in their organism is going to be super low, so they cannot be infectious anymore. And it's kind of depends on the medical system as well. So if they have an access to this kind of medicine, etc., so
they kind of safe. They like safe. If you have medicine,
yes.
If
they take the pills regularly, if they like really pay attention on their health status, yes, they're safe.
Okay. And I wanted to ask you about you as a person. What are you doing on your free time?
Yeah, that sounds.
Tell us about your hobbies. Who are you? Are you living here, or maybe? I know, but let's tell.
Well, let's say there is a nice book written by Strugatsky, which has a name. Monday starts on Saturday. So for us, for scientists, it's mostly true. There is like, if you could see, there is plenty of people actually, despite it's a weekend. However, yes, you know, you have to have your life and work balance. So I'm trying my best to have it from time to time. So yeah, well, I have multiple hobbies. Let's say like, I don't know, mountain climbing, surfing, capoeira, etc. But I don't have much time on them usually.
But it all sounds like dangerous hobbies.
Well, let's say I'm adrenaline dependent person.
So you like risks?
Well, if you do things properly, you minimize the risks.
Okay. So mountains, surfing, and what else?
Capoeira was the last one, but because of pandemics, we didn't have a chance to start the trainings for a year.
Unfortunately, what can we do? Okay, I think. So thank you for a nice talk.
Thank you.